This example is going to have us working with interpreting a position time graph and then translating that into a velocity time graph. So we have a position time graph shown below, and then A and B are asking us to find which points on there are going to correspond to lowest velocity and maximum velocity. All right, so let's take a look at the curve. Always good to just highlight or recognize what your axes are. So this is a position time graph. They told us that, but we should be able to tell that by just looking at it. So on that horizontal axis here, so we've got time. And then on the vertical axis, we have y, and we have been just working with x on that vertical axis, but y is also a coordinate that we can use for one-dimensional motion. And this just would tell me that this is an object that is moving vertically, right? So maybe it is a ball or an elevator or something like that, right? So it's something that is moving in that vertical direction. Okay, so anytime I have position time graph, we want to always be thinking the information that we can pull from this is slope is probably one of the most important things, right? And slope is our velocity. And so the slope at any point will tell me about the velocity at any point. And so in this particular case, they asked us for where the object is going to have the lowest velocity. So the slope is going to equal the velocity. So if the slope is 0, that's going to be our absolute lowest. If we have a less steep slope, that's going to be also a lower velocity, right? So if we look at this particular case, so I can run through, so something I might do just on something like that is just throw some tangent lines in here at different points. And this can kind of help us quickly answer any questions, right? So the slope at each of those points, when I put those tangent lines, that's telling me about the instantaneous velocity at those points. And so I can think about what's going on throughout that range of motion just by kind of more clearly articulating those specific tangent lines. So if I'm looking for the lowest, I'm looking for the points where I have this the least steep slope or a slope equal to 0. And I do have a couple of points where that's the case. So down here, slope is equal to 0, right? So that means my V is equal to 0. So VA equals 0. And then up here, I also have slope equal to 0. And so VC is also going to be equal to 0. I do want to mention the difference between these 2 points. So they both have a slope of 0. But point A is going to be something we call a turning point. So if we look at point A, so I'm going to get rid of some of this stuff here. So if we look at point A has a slope equal to 0 just at that specific point A. But if I look right before and right after A, so right before A, I've got this slope. Let me do that in a different color. Right before A, we've got this slope, and then right after A, we have this slope. So that means the object is moving as it goes into point A, and then it is also moving as it comes out of point A, that one instant in time. And if we look at the slope before A, so that is a negative slope, and then the slope after A is a positive slope. So the changing in the direction of the slope means that our object changed direction. So when we have a minimum or maximum on our position time graph, those are going to be what we call turning points, because our object is going to be just changing direction. So it's just momentarily has a velocity of 0, and then it's going to change direction and start moving again. If we look at point C up here, point C is a little bit different. So we have a whole region where our slope is equal to 0, not just one specific point. So I have an extended period of time where that slope is equal to 0. So I have an extended period of time where my velocity is at 0. So that means that at this point, we would say the object is at rest, right? So it has a time interval over which that velocity is 0. So the object is at rest. We would not say the object is at rest. Generally, I mean, it's instantaneously at rest, but we would not say the object is at rest at point A. We would say that that is a turning point. Okay, so for A, which points have the lowest velocity? So that we're just going to say A and C. So point B is saying at which point do we have maximum velocity? So if lowest velocity is where our slope is lowest, maximum velocity is where our slope is maximum, or steepest. So again, if we just kind of look through that range of motion, we're looking for the point where the slope is going to be the steepest, and that actually is going to be this point B here. So steepest slope means we're moving the fastest. And then for C, so it's going to have us sketch the velocity time graph for this particular object. And I'm going to add in there, we're going to sketch the approximate velocity time graph. So I think I've mentioned a couple times now, when we do these graphs, we're very rarely ever going to put actual numbers along our axes. We're looking for general trends, right? What's going on in this region? Is it speeding up? Is it slowing down? Is it changing direction? What kind of general information can we get? So I also will frequently, if I give you this, I'll put the position time graph and the velocity time graph just directly below. And that's because I think it can be helpful to line up those time axes. So here I'm going to go ahead and put, so this is Vy, so velocity in the Y direction, and this is going to be our time. And then if I have the graph directly below, we can kind of line up these points, right? So here's point A. Sometimes that helps us construct that velocity time graph if we have these points or intervals kind of along our graph. So the quickest, easiest ones, I think, to go ahead and indicate the points are A and C. So we already talked about that the velocity for A and C. Those are both points where our velocity is 0. So I'm going to go ahead and put these. So on my graph, this is my 0 for my velocity. So at point A, I am momentarily having a velocity of 0. And then at point C, remember we said our object was at rest, kind of this whole section that is flat here. So I'm going to go ahead and actually I'm going to make this not black. I'm going to go ahead and make this a different color so we can kind of see it better. So that whole region around C, right, this is going to be my velocity. My velocity is going to be 0 for this extended time. And that just means that our object is going to be at rest. Okay, so then to fill in the rest of this, we kind of think about just, well, what's going on in the region? So I want to think about what's going on in this section here. So I have kind of a general description of motion I can make here. And then I'm going to have a general description of motion I can make for this next interval. And then again for here, right? So I can talk about before A, we can think about what's going on. And so before A, I want to just recognize first, is my slope constant? So no, my slope is not constant. There's a changing slope. And so then I'm going to think about, well, how is it changing? Is it getting steeper or is it getting less steep? And I think a super quick way to do this is just to throw some tangent points like early in the interval you're looking at and then toward the end of the interval you're looking at. And if I just throw these two tangent lines in there, I can see that my slope is getting less steep, right? So for this particular interval here, or this region in here, my slope is getting less steep. So that means that we're slowing down. So I'm going to slow down in this section. So we'll kind of summarize over here what we're doing. So prior to A, so we're slowing down. And again, we know that because my slope is getting less steep. And then the other thing we care about is which direction are we going? Are we going the positive direction or negative direction? And the slope for that entire section before A is a negative slope. So that means this is going to be negative direction. And so if I know these two pieces of information that we've got from that position time graph, then I can go ahead and hop down to my velocity time graph and we can indicate that information on that graph. So a thing that I will super overly emphasize, I guess, because I think it gets really confusing. So on that velocity time graph, the 0 along the velocity axis is right there in the middle. That's our 0 point. So that means that everything above, so this is positive velocity. And I'll say up here, this is big positive velocity if I'm going this way. On the bottom, so if I'm below here, so this is going to be big negative velocity if I keep going this way. right? So if we look at prior to A says we're slowing down and we're in the negative direction. So if I'm in the negative direction, I have to be on the bottom half of this graph. And when I'm on the bottom half of this graph, remember that this is your 0 is here. So I'm slowing down. That means I have to be starting somewhere out here. So this first section, I'm starting at some, and if it's helpful to throw some numbers in here, like just like throw some numbers in here. Maybe this is negative 10 meters per second. So I'm starting at a speed of maybe 10 meters per second, and then I'm going to slow down to 0. So I'm going to head up this way. So that slope is going to be positive because I'm on the negative part of the velocity time graph. So I'm slowing down to 0. Then we're going to look at our next interval. So our next interval, so between A and B, so between A and B, again, we want to think about what's happening with the slope. And then is it positive or negative? So let me get rid of those pieces that I already had in there. So again, if I just throw a couple of tangent lines in here, so when I'm closer to A, I have a less steep slope. As I get close to B, my slope is getting steeper. So that means that we are speeding up as I go from A to B. So speeding up. And then throughout that entire region, my slope is now positive. So this is positive direction. Okay, so from A to B, so I'm going to hop back down to my velocity time graph. Remember, this is where we put A, this was B and C. So from A to B, we're going to be speeding up, and that's helpful because we are here at A, I'm at 0. So I'm going to be speeding up, and I can speed up from point A in either direction, right? So if I do this, this would be speeding up because I'm going from 0 to a bigger speed, a larger speed in the negative direction. Or I can speed up here. If I'm above my 0 here, that means we're speeding up in the positive direction. So this one's speeding up in positive direction. This one is speeding up in the negative direction. So we need to just check which one are we doing. So we are speeding up, and we said the slope was positive from A to B. So that means we're speeding up in the positive direction. So that means I'm going to do something like this, right? So I've got a positive slope on my velocity time graph, moving away from that V equals 0. So that means we're speeding up, and we are on the positive side of that velocity time graph. All right, let's look from B to C. So in the B to C region, so between B to C. So in that region, again, if I just throw some tangents in here, so here my slope is like that, and then here my slope is like that. So as I'm going from B approaching C, my slope is getting less steep. So that means we are slowing down. And if I am slowing down, the other piece we want is the direction. So from B to C, my slope is still positive. So this is positive direction. Okay, and then remember when we got to C, we're back at 0. So between B and C, so we're going to be slowing down. So what I had left at B, we were up here, some positive velocity. Now we're going to slow down. And we're going to slow down in the positive direction. So I'm going to slow back down, and we're actually going to slow all the way back down to 0 because we know that we kind of level off here on this point. So I'm going to slow back down to 0. So here I have a measurable positive velocity. So I'm moving in the positive direction. This is showing me slowing back down to 0, where then we are at rest. Okay, so this graph that we've shown here in kind of this reddish pinkish color, this is a velocity time graph that corresponds to that position time graph above. Before I stop here, I want to just highlight one thing that does just tend to get super confusing. So I've already mentioned it a little bit, but when I am looking just at a velocity time graph, if we're looking at this section here, it's important to remember that this section is showing a slowing down. So I think there's a tendency, because it has that positive slope, to think about our object speeding up. But if I'm on the negative side of my velocity time graph, remember this positive slope on the negative side of the velocity time graph means that I'm starting with some velocity, and I'm getting closer to zero. So this section is showing slowing down on that velocity time graph. I'm just slowing down in the negative direction. Okay. We will do lots of practice with these. We have a lab where you will create some of these graphs. But this is something that I think is pretty important to understand, to be able to go back and forth between these position time and velocity time graphs to interpret those ranges of motion.